All right, final stop. Criteria C. So let's get this writing done. You should have already finished your table of results. If I go down, you should have finished your graph as well. You would have handed that in. Now we're into conclusion. First question, what happened to your dependent variable as you change your independent variable? This is just a statement, so everyone's going to have the same one. As the number of bulbs increased, that is your independent variable. The current flowing through the circuit, that is your dependent variable, and you want to state what happened. Next up, how does your data support your conclusion? Okay, you're just finding out and you're saying from data means you have to go into the numbers, why what you said happened. So for me, I kind of went through the analysis of a graph. That's what you were doing as well. An analysis of data from our graph can determine the relationship between our two variables. That's great. What we did was we looked at the line of best fit, and then we went ahead and we found the slope of that line of best fit. We noticed that the two share a negative correlation. Negative correlation meaning as I increase one, the other one decreases. So we get something that looks like this. A positive correlation would be something that looks like this. Because I have a negative on the slope, it's a negative correlation. Do you think your data you collected was accurate? This is just a statement, yes or no. It doesn't mean yes or no. It means the data collected was accurate or not accurate. You have to choose. Next up, you need to go a little bit further. Explain your answer here. How do you know you were accurate? You have to use data to do that, and you also know this. You got to show your equations for it too. If you are struggling, maybe you're back here and you're going, how on earth did he do this? So I'll show you how to do it quickly. All right, you go insert, then you go to special characters. No, you go to equation. Then I want slope. Okay, I'm going to type in slope equals. And now if I want this rise over run thing, I'm actually going to click here and I'm going to go AB. If I want to go around this, I just click the left or right arrow key. So I've got the top right now, I'm going to go rise, and then if I click the right arrow key, I'm going to go down. Seems strange, but I go down. So I'll click right arrow key, boom, we're down. Now I can go run. And if I want to get out of this, I click the right arrow key again. Done. If I want to do several of these, what I'll do is instead of me going through that every time, I can copy one of these and I can paste it. And whenever I do that, if I go back into it, I'm going to go back into it, I'm going to do the opposite. Instead of going right arrow, I'm going to go left arrow. All right, I'm now in the section below run. I'm going to change this for a number. For my number, my run was 10. If I want to change the rise, I'm going to click the left arrow again and get into rise. Now I can delete these and put in -5. You see how this is actually not that scary to do, but it might be something new to you. So that whole couple tricks, I hope you can use them. All right, you do have to show your equations. Those of you who are working on paper, hey, good for you, but later on you'll have to know this step anyways. So anyways, back to 12. How can you be sure that your data was accurate? You got to show your percentage error between experimental and theoretical. Mine was 6%. I talk about it up here, I show the data down here. Hypothesis, copy your hypothesis below, just copy paste. Next up, discuss whether your hypothesis should be accepted or rejected. Now you have to talk about precision and accuracy. If you don't remember what these are, use the videos to help yourself explain it. You want to talk about how accurate your answer is and how precise your data was. You have to talk about the two, and really what you're looking for is, do we trust your data? Do we trust your data that we can accept the hypothesis, or do we trust your data that we should reject the hypothesis? Maybe we don't trust your data enough that we can't actually really say whether it's accepted or rejected. You have to make that determination on your own. All right, next up, discuss whether the experimental method was sufficient to answer the research question. Okay, this one is if I'm not sure, if I cannot give you an idea of if we can accept or reject the hypothesis just because our data is not accurate enough and not precise enough. That's where we might have the experimental method. Maybe that wasn't the best way to answer the question. So If we have that problem, then we're going to have to answer this section. If we don't have that problem, we still have to answer this selection section, but it's a lot easier. If your experimental method was good enough to answer the research question, you just write the experimental method was good enough to answer the hypothesis, the research question, because our accuracy and precision for it were spot on. If not, then we have to go into more detail. Outline how the range of values of the independent variable was sufficient for this investigation. So for all of us, our range of values was how many lights are there. We only had 3 lights. Was that enough to answer our question? Maybe if we didn't get enough data to have a high degree of accuracy or precision, we don't really have enough. So maybe we need to consider maybe adding some more light bulbs. If we did, that's where we talk about it. Precision of results. We've all done this before. Again, use data to identify. That means you're going to have to show equations. Outliers in the data. Are there any things that don't fit within that line of best fit? I know for a lot of people, whenever they had 2 light bulbs, it seemed a little strange. You want to discuss why that might be true. Methods. Okay, this is where we get into evaluation and kind of a cycle. So in your unit cycle, I kind of touched upon it right here, evaluation text structure. This is actually, a text structure is something we use in formal writing. And it's where we go through the same basic ideas. You answer one thing and then you repeat the process. So you answer one question, you answer the next, and you generally repeat and go back. So I actually kind of copy that into here just to show you what it might look like. So methods, I'm going to think about only the methods. That's the steps I took. So some strengths of the methods used in this investigation were blah-de-blah-de-blah. Great. Write them down. Now, we're done that one with strengths. We're going to go back up and repeat the process for weaknesses. All right, back up to weaknesses. Some weaknesses of the methods used in this investigation were blah, blah, blah. Next up, the next step down, how would it change your results if, okay, so we have weaknesses. I got a weakness in my method. How would that change the accuracy or precision of the experiment? This is really where you are talking about, if I were to change the way I did this, how would it change my results? How would it change the accuracy of my results? How would it change the precision of the results? You also have to talk about not just what would happen, but why. This is due to ... For each weakness, repeat this cycle. Go around and around and around. You should have several of them, really. B, explain how you could make your results more precise or accurate next time through a change in your methods. Okay, so oh my goodness. Anyways, so what you want to do is you want to talk about how you're going to fix this, how you could fix this. Now, we aren't expecting you to go back and redo the lab, but if someone were to do this lab again, what are some suggestions you'd give to them to help them get better data? So maybe the experimenter could use a different piece of equipment. Maybe they might adjust their equipment slightly differently. Maybe they might change the order in which they do things. This is going to help the experimenter to produce more. Is it going to be accurate or precise? And again, it says through. That means this is due to. I want you to tell me why that would happen. Now, easy enough. Equipment is the exact same thing as methods. I could literally just copy this in to here. Is there a better way to set up the equipment? Easy. What are some ways you could improve your data through better equipment? Easy. Next up, accurate. Accuracy, you've already done in a previous one, and precision, you've already done in a previous one as well. Moving on, fair test. All right. Now it's up to your control variables. Were you able to actually control them all? That means keeping all your control variables the same. Describe any issues you had. Does this look familiar? Some weaknesses of the controlled variables used in this are... Does that look familiar? This weakness would have altered the... Look familiar? It's the same text structure. If you get this text structure down, then it's going to make your life easier. You have to show all these pieces. Same thing, describe ways in which your controlled variables could be held more consistently to one value. Again, this is help for the experimenter in the future. What could they do differently to make sure that their controlled variables stay the same? All right, variables you should have controlled but didn't. So this is any controlled variables, maybe, I don't know, maybe you have to change the temperature. These should be real things, not made up things. You won't always have things that you should have had controlled but forgot. It's just true. And last thing, outline how these forgotten variables might have affected your results. Again, we're looking for, would they make them more accurate? Would they make them more precise? How would it change the slope? All that lovely stuff. And guess what? You're done. At that point, you can hand in either your paper copy with me, or you can save it and send it in, turn it in through Google Classroom. All right, all the best.